In this video, we're going to talk about zeros and multiplicity. So the first thing I want to talk about is what does it mean? Like, what are zeros? What is multiplicity? Because I'm guessing while you may have heard the term zeros before, multiplicity is probably a brand new one. And you might be thinking she keeps saying multiplication wrong. And no, I'm actually saying the correct word. The word is multiplicity. All right. So let's start with zeros. What are they? Well, zeros are values that make the function equal to 0. Okay. Now, sometimes we will talk about zeros in the same way that we talk about x-intercepts. And so visually, if you think about your x-intercepts, right, every x-intercept has the y value of 0. That's the function value. That's why we oftentimes will talk about them in the same way. So how do you find them? Well, you can visually, okay, look for the x-intercepts. I don't know what I was just trying to write there, so let me try that again. Look for the x-intercepts if you have a graph. All right. Or, okay, or if you're in factored form, all right, set factors equal to 0 and solve for x. Okay. So those are zeros. Let's talk about multiplicity. Okay, multiplicity is a word, again, I'm guessing you probably never heard of it before, but multiplicity is how many times a particular number is a zero for a given function. Now, how are you going to know? All right. This is going to come from the exponent. Okay, exponent, and I'll do power as well, so you know what I'm talking about. Exponent or power in a function. Okay, for a particular factor. Okay. So when we're looking at a function, if you have, let's say, f of x is equal to x plus 1 times x minus 2. This factor would turn into a 0 of x equals negative 1. And this factor would turn into x equals positive 2. Because this factor only shows up once, this value of x minus 1 has multiplicity of 1. The factor is 1, multiplicity of 1. This factor, x minus 2, only shows up one time, so it has multiplicity of 1 as well. So I'm just going to put multiplicity to, I always spell this word wrong, multiplicity of 1 for both. Okay. Now let's see, we change things. Let's say instead we have f of x is equal to x minus 1 times x plus 3 to the 4th power. Okay. So this factor, x minus 1, would give me the 0 of x equals positive 1. Now, this factor shows up once, so this x equals 1 has multiplicity of 1. Apparently, if I spell it fast enough, I do better. Or write it fast enough. All right, x plus 3 would become x is equal to negative 3 as my 0, but this factor shows up 4 times. It has an exponent of 4, which means I would have x plus 3 times x plus 3 times x plus 3 times a 4th x plus 3. So if it shows up 4 times, it has multiplicity, in this case, of 4. All right, that 0, that x equals -3, shows up 4 times. So instead of writing out all 4 of them, we just say it as multiplicity of 4. All right, so let's get into the actual examples here. All right, so we have this function. It says determine the zeros and identify the multiplicity of each of the zeros. All right, so I want to go into this function. And we actually have this 3 as a factor as well, but because it doesn't have a variable x, it's not going to actually create a 0 for us, right? We can't make the function equal to 0 when it says 3. So we have x equals 2 here. That is going to give me a 0 of x equals -2 with, and I'm just going to use the symbol with, multiplicity of 1, right? X plus 2 shows up as a factor just once, so it is multiplicity of 1. We also have a factor of x minus 7, so that would become x equals +7 with multiplicity of 1. It also shows up once, so each of these has multiplicity of 1. So those are the zeros and the multiplicities. All right, so let's move on to example number 2 here. We have a function, we have x minus 3 to the second power and x plus 2. Determine the zeros. All right, so this first factor here, x minus 3, would turn into x equals +3. Because it has a power of 2, that means we're going to say it is with multiplicity of 2. And we have another factor. This x plus 2 shows up, so x plus 2 would turn into x equals -2, but that factor only shows up once, so that would be multiplicity of 1. Okay, so that's example 2. Let's look at example 3 here. We only have one factor, right? 3x plus 2. Now, you want to be careful because we have a number in front of the x, and yes, we normally would have a 1 there, so we want to be careful because of the 3. So if you want to, if you can't quite figure it out in your head, take that factor, right? 3x plus 2, set it equal to 0, and then do what you need to do to solve it. So I'm going to subtract 2 from both sides. Go ahead and divide both sides by 3. So I have a 0 here of -2/3. Okay, but I also need to talk about the multiplicity. So with multiplicity of, whoa, hold on a second. There we go, of. So if I look at this function, it has a power of 3, which means this factor would show up 3 times, which means the 0 here has a multiplicity of 3. Okay, and I'll box that one up so you know that one's done. All right, so there's no other factors there, so example 3 is now done. Let's see what example number 4 looks like here. All right, given this function, determine the zeros. All right, so we've got 1, 2, 3 little factors here, and each of these factors is going to give us some zeros. All right, so we've got x minus 3. So x minus 3. And by the way, you can do this little set it equal to 0 thing and solve if you need to for any one of these. So x is equal to +3. However, this factor shows up twice. So we're going to say this is multiplicity of 2. Okay. Now I have x plus 2 here, so I'm going to do x plus 2 equals 0, subtract 2 from both sides, x is equal to -2. This factor only shows up one time, so I'm going to say this is multiplicity of 1. All right, and we have one more factor here, which is 2x minus 5, but that's raised to the 4th power. So we're going to get to that 4th power in a little bit, but I just want to take this factor here. So 2x minus 5 is equal to 0. I'm going to add 5 to both sides. So 2x equals 5. Divide everything by 2. So x is equal to 5 over 2. However, the multiplicity here, so this factor shows up 4 times, so this 0 would show up 4 times, so it is a multiplicity of 4. All right, so the final answer for example 4 here, you'd have to tell me x is equal to 3 with multiplicity of 2, x is equal to negative 2 with multiplicity of 1, and x is equal to 5 halves, or 5 over 2, with multiplicity of 4. For the fractional answer, you do not have to change it into a decimal. In fact, I really don't want you to, so just leave them as fractions, please. All right, so that takes us through the examples where I'm giving you the functions and you need to find the zeros in the multiplicity. In the next video, I'm going to go ahead and reverse it. I'm going to give you the zeros in the multiplicity and we're going to write a function. If you have any questions or concerns on this, send me an email or send me a message, and I hope this helps.